Hello, everyone. Welcome to our webinar, where we will be walking through how to use MindsDB, a machine learning platform with Looker to enable predictive analytics directly in your BI tool. I'm Erik Bovee, Vice President of Business Development at MindsDB, and I'm joined by Erik Carr, who is Senior Director of Enterprise Analytics at Looker, now part of Google, and Natasha Seelam, Machine Learning Researcher, and Patricio-Cerda Mardini, Research Engineer at MindsDB. Incorporating machine learning into business intelligence workflows has become common practice in the last few years, and BI tools benefit from recent developments to democratize machine learning by automating many of the complex tasks previously reserved for machine learning engineers. We believe there are further fundamental improvements to the design of machine learning applications that can broaden its adoption and best support business intelligence, and Looker is a really great case study. Looker is a business intelligence and big data analytics platform that not only has a suite of extremely powerful tools, but Looker has strong SQL support and is extremely customizable and flexible. Today, Erik will give you an overview of the Looker platform and its benefits, and then we'll show you how you can turn on machine learning predictions in Looker using simple SQL commands with MindsDB, essentially turning Looker into a crystal ball. We're going to have 45 minutes of presentations and 15 minutes of Q&A. And if you have any questions during the presentation, please use the questions tab and we'll answer them as we go, and we can take more questions in the final period. I'd like to thank you all for attending, and I'll turn it over to Erik from Looker.
Thanks, Erik. So here at Looker, our goal and our mission has always been to empower people through the smarter use of data. And how we've done that has really evolved over the years as part of Google Cloud, but we are able now to help more companies and to help more people join us in our mission. Over 2,000 companies partner with Looker today to harness the power of their data to empower their people to drive successful business outcomes and to deliver better experiences for their customers. And the need for better customer experiences has been the catalyst for digital transformation at leading enterprises around the world, and the Looker's platform ability to deliver timely and actionable insights and to infuse data into any business workflow has really made it the go-to choice for those companies. Digital transformation is really a profound shift in the way that companies are using technology to deliver value to their customers. It's without doubt the #1 priority for technology leaders today. Out of all the areas that we can use to drive digital transformation, the #1 area of investment at the moment is data and analytics. But we're not just talking about the conventional understanding of data and analytics. According to Gartner, spending and focus on traditional query and reporting BI environments will shift dramatically to analytics integrated into business operations and digital solutions. This is from Gartner's Data and Predictions through 2022. And we're talking about a fundamental change in the way that we're used to thinking about and working with data. Forrester calls the companies that are doing this well insight-driven companies. These are the companies that are using data to really drive growth and to create differentiating experiences, products, and services. The idea is that data is not just something that we analyze, but actually something that can be infused into everyday business processes to make business employees smarter, to optimize operations, or to really drive new streams of revenue. We're talking about really expanding the idea of traditional BI and bringing it into the modern era of data-driven experiences. So Looker's platform offers a unified view of access to the truest, really most up-to-date version of your company's data. With this unified view of the business, you can choose or design data experiences that really let your people and systems get their data delivered to them in a way that makes the most sense for their needs. Data experiences can represent any number of ways that companies drive data for value. That could be anything from modern BI and analytics serving up real-time reports and dashboards that inspire people to do more in-depth analysis, infusing relevant data into existing tools, using them for existing workflows, supercharging operational workflows with real-time data, pushing it downstream to other APIs, or even building out custom applications, providing data tools built to deliver results you need as and when you need them. Looker provides this in a number of different ways. The three main ways that Looker makes this technology available is by providing an in-database architecture. And what that means is that essentially you're leveraging the power of a modern cloud database. These databases are typically significantly faster, much cheaper than their predecessors. They scale out easily, and that live connection to the database provides a real complete view of your data without having to move it out into the application layer. So we're not going to extract all of your data from your database into Looker and do something with it there. We believe that you've made the investment in those cloud databases and that we can leverage those databases to use their power. This is essentially ELT instead of ETL. How we do that, we use a semantic modeling layer. So the semantic modeling layer is built around a centralized definition of all of your business rules and all of your business logic. It separates the business logic from the physical data. So that means that you can reliably apply consistent governed definitions across your KPIs so that both your technical and your non-technical people are always working with trusted and reliable data. Third, we're API first. So our APIs for data give builders the tools that they need to deliver any data experience anywhere. That could be custom apps, proactive rule-based alerts, scheduled reports, automated workflows. We provide SDKs as well. So if your developers are more comfortable working in Python or R or JavaScript, we allow them to do that. We're multi-cloud. We're built on the cloud strategy of your choice. So that could be GCP, it could be AWS, or it could be Microsoft Azure. And we're committed to that. But really, Looker's unique architecture is uniquely placed to take advantage of some of the really exciting things, such as automated machine learning with MindsDB. So that was basically a quick overview of how partnering with Looker can help you define a data strategy that drives your growth. And now I'm going to pass it back off to Erik Bovee with MindsDB so that he can talk about how MindsDB can help you leverage predictive analytics in line with your data. Thank you.
Thanks a lot, Erik. So I'm going to walk you through kind of a high-level introduction to MindsDB, what it does, and then we can dive into an actual demonstration of visualizing predictive results using the BI tool. So MindsDB is an automated machine learning platform that performs many of the operational tasks of a data scientist and significantly reduces the operational overhead of training and deploying machine learning models. But one of the coolest things about it also is that MindsDB performs your machine learning, training and inference directly at the data layer. So it connects to your database and creates predictions that can then be accessed and manipulated as database tables. We call them AI tables. And those predictions are then directly accessible within Looker. So to give a little context, one of the problems with machine learning today is that workflows and data pipelines often resemble kind of a research project. Your data lives somewhere, let's say a data lake. It can be in the Looker data store. You might have flat files. And your machine learning application is often a bespoke, purpose-built, let's say, artificial neural network built with Python that sits as an entirely separate application. In order to train your model on your data, you have to extract the data from various sources often. You have to transform it. You load it into your machine learning application. And then once your predictions are done, you reverse the process and you take your predictions and put them back into your database or load them into your BI tool. And there's a lot of work. It's not particularly efficient, and there's kind of a lot of toing and froing, and you have to do a lot of purpose-built components, hard-coded data transformations, and data pipelines. So this can be solved by running machine learning. Our idea was that this can be solved by running machine learning at the data layer, directly on your semi-structured or structured data. And our intuition was that there are many benefits to moving machine learning down the technology stack. And one of these is just tremendous operational efficiency. And so why is this? Well, there's some compelling theoretical reasons why this works well at the data layer. Structured data in your database has a lot of similarities with machine learning models, and both can be treated in similar ways. So your database has code and schemas that define it, and your machine learning model has codes and graphs that fit the model. And in fact, columns in your database kind of equate to features in a machine learning model. So there isn't a lot of transformation that needs to happen on structured or semi-structured data in your database. And often, if you can perform machine learning directly on the data, you also save a lot of the time with all the extraneous ETLing that happens. So your machine learning stack, if you connect MindsDB directly to your database, your machine learning workflows basically go from the diagram on the left to what happens on the right. So this is what it looks like with MindsDB. Instead of operationally intensive, application layer models with lots of data pipelines and transforming and pushing data back and forth, you have MindsDB integrated with the database. And the way that we do this is conceptually really simple. You just connect your database to the MindsDB cloud service. The query planner in your database recognizes SQL or other database commands, depending on what you're using, that are intended for the database and handles them as normal. And machine learning queries are routed to the MindsDB service. So MindsDB trains an appropriate model on the data directly in your database, and then returns predictions in the form of database tables. We call them AI tables. And these can be joined with other tables. They can be queried directly from your database. And here's how it works in practice. So I'm just going to show you a really simple example. Imagine you have some information sitting in your SQL database on income and debt. This is consumer income and debt. So across the x-axis is your income, and then actual data points on your debt is on the y-axis. You want to query the data. How much debt does an individual with 80K income have? So you write a SQL query, and 80K returns an exact figure, 25,100 of debt. But what happens if you want to query an income figure which doesn't actually have a data point within the database? It returns a null value. There's really nothing there. And you can't really do anything theoretical with this. There's quite obviously, if you look at the points along this graph, there's quite obviously a trend here, right? There's some information and it should be very easy to forecast, but the database won't do this for you. With MindsDB, what happens is you can fit a debt model to the income, and this can be made available as an actual table in your database. So then you train your machine learning model in MindsDB on the debt and income model. And then when you do a query, it returns an actual predicted result for you. So it's really that simple. So what we're going to do now is we're going to turn it over to Natasha and Patricio to give a demonstration in slightly more concrete terms of how this works on more complex data sets. So I'll hand over to Natasha.
Great. So in the context of the next components of the talk, I'm going to be talking about some of the technical elements. And in particular, I'm going to cover these three things. First, we're going to talk about an exact live demo using time series with Patricio, one of our researchers. I'm going to front load the question and how we can use both Looker and MindsDB to be able to, one, forecast and then visualize a forecasted prediction of time series. Then we're going to look under the hood. So one of the core tenets of MindsDB is that the user should have control and transparency around the AutoML process. So I'm going to go through the framework that we have to be able to deploy machine learning models and how advanced users can actually customize this to the data that they see fit. And then lastly, we'll discuss some future features that we have in the pipeline. So with that, I'd like to go over an example. And in particular, I'm going to choose a fairly challenging one with time series. And we're going to be able to forecast a prediction in the future without ever leaving the database. Now, to front load this problem, I'm going to give you an example of data that we have. So in this case, we have information around taxi trips in Manhattan in New York City. Now, we could put on the hat of a public service official looking to predict demand over time. So for example, in fact, we want to make public transport more available, so we want to figure out the hotspots. And so by predicting an increase or decrease in fare, we can correlate that to demand. So we might have a data set, and in this case, we have nearly 130,000 hours, where we want to pick key features. So for example, the vendor ID can correspond to different companies that host these taxi services. The pickup date time is the particular time that someone is picked up in a taxi trip. And of course, we have data spanning from 2009 all the way to 2016. And lastly would be the fare amount. Since this is a time series problem, we're going to use prior hours of information of how much it costs to be able to forecast if the demand is increasing or decreasing. And so with that, I'm going to turn it over to Patricio, a pre-recorded video, if you could just hold on a moment.
Okay, so we will take a look at how Looker and MindsDB can be used in parallel to visualize predictions for the data that lives in your database. Now, there are several ways that you can access MindsDB. We recommend our cloud service, or if you want a local instance, there's Docker. For this demo in particular, I am using MindsDB locally, and I have connected it to my Looker cloud account here. So let's start with MindsDB Studio, which is what you're seeing right now. It's our graphical user interface that can be used to add data sources, basically your databases, and from them getting data sets and training and querying predictors. In this case, we will be connecting to a ClickHouse database that you can see is live if we, of course, there is a port specified for it with a certain username. And if we go into the settings and I type my password, and well, the name of the integration as specified on the configuration file for MindsDB, it says connection OK. So indeed, we are live with ClickHouse. In fact, I have my instance of my ClickHouse instance right here. And I can show you there are several data sets that I've previously used, but in this case, we'll be focusing on the trip data database, which is basically the data that Natasha was mentioning just a moment ago. So if we wanted to see how it looks like, remember this is a pre-processed or aggregated version of the data. We have 3 columns. So we have for each taxi company, the hour on which there might have been anywhere between dozens or thousands of different taxi trips. Each of them had an associated fare, and we summed them all in an hourly rate. So that's how the processed data looks like. Now, we can easily add this as a new dataset from ClickHouse. The way to do it is give a name. So we can say trip data, like this. The database is data, as we were seeing in ClickHouse, and then I can select everything from my table. In this case, it's the _tr split for training. So this is the training dataset. And it has been created. We can see the dataset now in the dataset tab. You'll actually, let me delete this one because it's a previous version, but you'll see that there are some other queries here that were executed previously. In fact, the first one is exactly the same query as the third one. Now you can preview how the rows look. So this is what we already saw in ClickHouse. So basically, again, for each vendor, you have in an hour, in any given hour, you have the total amount of fares that the company received. Now, there's an interesting functionality that we have in the graphical user interface, which is the data quality process, where MindsDB takes a look at how each column looks, and it will give you the distribution of data. It will let you know if there are possible or potential biases in your data or outliers. In this case, we can notice quickly that for the hours that are registered in this table, there's actually like a period between 2014 and 2015 where there's no data. And this might be worth keeping in mind. On the other hand, for the companies themselves, we can see it's not quite balanced, though in this case, it's not really a problem. So we can just go ahead and train a predictor from the predictor staff. Now, it's quite easy. The way to go about it is selecting the data from which you'll train, give a name to the predictor, and then specify which column you want to forecast. In this case, we want to know how the fares are going to evolve into the future. Now, as this is a forecasting task, we need to access the advanced mode and specify or let MindsDB know that this is a time series prediction problem. And in particular, we will be ordering by the pickup hour column or sorting by it, and then grouping by the vendor ID. This is to say, each different taxi company will be treated as a separate time series, even though in the backend of MindsDB, we will only really have a single model that will be able to predict for all of them at once. To keep it simple, we will be predicting the next hour, and for that, we will be based on the previous 12 hours of data. So basically using the previous 12 rows. And that's that. We can hit the train button, and after a few seconds, it will, like the predictor will appear in the list as currently training. Okay. This might take a while. In this particular case, I believe the predictor takes about half an hour. So I've taken the liberty of pre-training a couple of predictors for the data. I will now show you how this looks, or how this can be integrated from Looker to get predictions out of a trained machine learning model. Right, so this is my Looker Cloud homepage. I want to go to the Develop tab, and inside it, go to the SQL runner that Looker has. You will notice that I have a handful of connections already in place. In particular, we will be using the aptly named Patricio demo, which is connected to my local MindsDB instance. Remember, you can use MindsDB from the cloud, but in this case, I have a local instance, and this connection is basically communicating Looker with my machine. You'll see in the schema that there's a few databases, and MindsDB has a handful of tables. The predictors has like a summary of all current predictors. Commands is necessary for the SQL protocol to work, and then test and pre-trained are a couple of predictors that I have already trained. Now, what we will do is we will execute a SQL query right here, which I'll just run already. But in the meantime, what we will be doing is from the integration that MindsDB has to ClickHouse, specifying the database that is called data, we will retrieve a view that I specifically created to query for this demo, which is the trip data query example, named as D. And now from this object, from this view, we will be getting the fares, the pickup hour, and the vendor ID as data that the predictor will use. The cool thing is that MindsDB lets you treat your predictor, which is right here, and it's named P, right? This lets you treat your forecaster as data. And so you are abstracted from the complexity of setting up the machine learning model and training it. So it's quite cool in the sense that you've given some subset of your data to the model, which will return the forecasted fares. And that's why we make the distinction between the fares and the previous fares, which are what you have in the data that you want to try to query. Of course, this is data that the model hasn't seen previously, so it's a held out portion of the data to test how well it is able to forecast or predict the future fares. Now, there are a couple of things we need to do first in order to visualize the forecasts. We need to convert to measures both the previous fares, which is like the actual data points that happened, and then the fares column, which is the prediction. And finally, we need to sort by the pickup hour, starting from the oldest row going forwards. And then for visualizing, we can just use a line plot. And the end result is something like this. So of course, we want to customize the colors to be a little bit more clear. So let's say that the actual series will be in green and the predictions will be in blue. You'll note straight away that the first 10 or so values are not really accurate. And this is expected. It's due to the way that our predictor basically gathers historical data. And once there's enough data, it starts forecasting based on the previous values. And you can see that for the immediately following, for the T+1 prediction, which means the model's trying to predict only the next hour, and that's what's overlapped here, it is quite accurate. You can see that what actually happened in reality is close to what the model thought would happen. So we have a good forecaster in this model. And as previously mentioned, you can change, basically you can consider any taxi company. In this case, we have the DDS company, but I have another view, which is _2 right here, that has data from another vendor. Another company, which I believe is the CMT company. And again, the visualization shows that you have good forecasts for this other company with different temporal dynamics. We can make an additional, like a last test with an additional vendor. Again, it takes a couple of seconds to run, get the predictions, and send them back to Looker, but the end result is the same. You get forecasts for this third taxi company, which is called BTS. That's everything I had for this demo. I hope it gives you insights as to how Looker and MindsDB can be used in parallel to get predictions and then basically visualize them in a friendly way to get insights. Now Natasha will be taking a closer look at how MindsDB is able to actually produce the model that forecasts these values. And yeah, that's it. So thank you for your attention and stay tuned.
So now that we're done with the demo, I wanted to take a look under the hood to explain how MindsDB actually operates. And so earlier, Erik showed you about the AI layer, but in particular, you can think of this as 3 individual steps. There are the integrations, which we call MindsDB, and these are providing the SQL connections to allow us to query the models like virtual tables. The research team spends a lot of time, however, on the wrapper and the ML core. Now, MindsDB native, the wrapper, does a lot of the heavy lifting to operate all the ML functions in an automated fashion. This allows us to do data preparation and even type inferencing, meaning that when we have different types of columns of information, for example, numerical or categorical, we're able to treat them appropriately. The next step is the ML core or Lightwood, and this is where the algorithms live, or the sets of rules to allow us to transform these data types and build predictors. Now, to take it a step further, one of the goals of MindsDB is to have control and transparency to be able to customize data and processes for the user. And so we have an encoder-mixer philosophy that allows us to control each step of the data science machine learning pipeline. The first step would be the pre-processing step, which means we take different types of data based on what it is, numeric, categoric, for example, and we prepare it in the appropriate way to be able to be leveraged by a machine learning model. In the next step, we use feature engineering, and this can be a set of rules to be able to create a numerical representation so that the predictors can actually access information in the data. The last is the mixer itself, which is the predictive model, whose job it is to take the different types of data and create a model that is able to predict the output of interest. And to give you an idea of this flexibility, I'm going to go over an example specifically using time series. For example, we'll start with the data pre-processing step, where I'll discuss how we do some of the reshaping to allow our mixers to see time series as a sequence as opposed to rows and columns of a dataset. The next is feature engineering, where we handle the fact that we have not only different years, but different hours in the day that we may want to be trying to predict. And so we'll show some date time handling. And then finally, about how we deal with the model itself with a custom autoregressive mixer, allowing us to have refined control in our predictive power and our ability to model dynamics. Now, for the first step in data pre-processing, MindsDB can automatically reshape the data in the form of a sequence for time series. Very traditionally, there is often a sequence that goes into a time series. So for example, as Patricio mentioned with the 12 hours, you'd have to have a series of 12 pre to be able to predict the next step. But a data set would often have a form of rows and columns. And so MindsDB has a data pre-processing step to allow us to transform our data in the sequential form for our machine learning models. The next step is date time handling. When predicting temporal dynamics, we need to be concerned with not only the minutes and the hours, but also the date. For example, dynamics might change over time. So to do this, we create a disambiguated interval using sinusoidal components of the date. So for example, the seconds, the minutes, all the way up to the years are represented in these components, so we can predict on any time scale. The next I wanted to talk about is a little bit about the groupings. So as Patricio had mentioned before, there are 3 different companies we were considering, indicated in this figure with the blue, the red, and the purple curves. Now the scale and also the periodicity, which is the frequency of the spikes, might be quite different. And so traditionally in time series, oftentimes a single model is built for each group, but this runs into several problems. First, the compute resources to be able to build these models scales with the number of models you have to build. And secondly, it can be quite tricky to build these sorts of models, especially when some groups might not be as represented as the others. And so as part of our feature engineering, we also included dynamic normalization. And to explain this simply, if you look on the figure on the right-hand side, you're looking at different airline carriers and their late arrivals. Now, the y-axis is indicating the number, and so it's a quantity. And I want to focus specifically on the gray curve at the very top and the purple curve at the very bottom. Now, as you can see, the scale is quite different, and also the periodicity or the frequency of these intervals. And so what MindsDB does in particular is to normalize this so that the scale and the dynamics can be represented from our machine learning models. Now, this removes the problem of having to train multiple models, but also allows you to compare between time series as you have a single model to be able to model all of these different patterns. Now, lastly, I want to talk a little bit about the mixers, which are the predictors themselves. Now, in order to get time series to work, we had to think of a very sophisticated mixer or a predictor model. And in particular, it's a 2-stream approach. One of the streams is specifically dealing with an autoregressive process, meaning it captures the temporal dynamics, the periodicity and the frequency of the changes of the fares. But the second is a fine-tuning element. So for example, the scales are different across the different companies. And so the second stream in particular deals with ensuring that you have the appropriate predicted value. The goal here is that if an advanced user wants to make changes to the mixer and have a particular process in mind, they can build it themselves if they do not want to use the presupposed defaults. And in fact, we have multiple examples of this modularity where we've incorporated the light GBM mixer, and we've seen people incorporate Optuna for hyperparameter tuning. Now, the last thing I want to leave you with is that MindsDB goes beyond just making predictions, and it wants to build the idea of trust in the user. And the way we can do this is by looking at both anomalies and confidence. So in the following figure, the green curve is the real data, the purple is the predicted, and the yellow stripes are indicating anomalies, so aberrant behavior and the time series information. With this, we can look to see if we actually see very strange behavior, or perhaps there are mistakes in the data itself. And so anomaly detection can be used to find faults or different changes in dynamic data. Next is the confidence estimates themselves, and this allows the user to know an upper and lower bound of the predicted values, giving you a range of what you might expect in the best and the worst case scenario. So to conclude, I'd like to think of some future features that we're currently working on behind the scenes. Now, there are two in particular we're developing. One is around continual learning, which is to adapt predictors to deal with the constantly increasing and changing nature of data. And the second is auto NLP. While MindsDB already supports classification and regression using text-based information, we wanted to take it a step further by using question answering in natural language to be able to predict structure from unstructured text data. With regards to continual learning, the goal is to be able to adapt a predictor as new input information comes in. Now, historically, with machine learning models, more often than not, if you have new data, you often have to wait till you have a sizable amount. And so therefore, you can retrain the model from scratch, which can be quite expensive. In the following, we're designing the infrastructure and the integrations with things like Kafka and Redis to be able to continuously listen to a changing input stream. And in this particular way, we can gradually adapt a predictor to be able to handle new information that comes in. Next, I want to talk a little bit about auto NLP. Now, in the following context, I'm going to give you an example using listings information with Airbnb. Now, as a human, you might be willing to read a few of these listings and ask the question, how many bedrooms are here? So in a following of these snippets, you might say, for example, a gorgeous 3-bedroom with a sunny view, we know there's 3 there. But to take unstructured information and pick out the salient components that are actually structured can be quite tricky in rule-based systems. And so we're leveraging powerful transformer-based machine learning models to be able to identify the salient components in text that correspond to a structured insight. And so currently we have a working MVP that in fact does exactly this. By querying a natural question like how many bedrooms, we can ask different data sets, in this case 4 different cities of Airbnb data listings, how many bedrooms are there? And through a quantitative insight, create a histogram-like approach to ask what the distribution of the number of bedrooms are across these different cities and across these different listings, and make a quick comparison. So with that, I'd like to summarize in some concluding thoughts. And that is, we first discussed a little bit about automating ML ops. And in particular, MindsDB makes predictive forecasting both for non-time series and complex data types like NLP and time series without ever leaving the database. Additionally, we champion control and transparency. And through our encoder-mixer philosophy, advanced users can make changes in any step of this pipeline in order to be able to treat their data in the way they feel is most applicable for their modeling endeavors. Next, I talked about going beyond just predictive forecasting and a little bit around anomaly detection and confidence estimates to ensure that the users have an idea of also the validity of their results and if they are robust enough for new data. And lastly, I talked a little bit about some upcoming features. One around continual learning, where we will gradually update predictors with new input data. And the second around question answering, where we will use natural language processing in order to query structured information from text info. And with that, I would be more than happy to welcome questions for any of us on the team. Feel free to use the chat if that's easier as well.
So in the chat, we're getting a few questions about benchmarking with other machine learning applications, and I don't know if we have. So I'm grabbing some resources, but I don't know if there's some kind of overall summary that we can say how this benchmarks against other publicly available machine learning models.
Yeah, I'm happy to answer that. So we both have internal and external benchmarks. On our internal benchmarks, every time we have new features, we test to see if we improve either in speed or performance. For external benchmarks, we look to compare between, for example, the OpenML suite. In particular, I think our performances are sort of in the average of the overall AutoML packages, but we are definitely the fastest. So that is one thing to keep in mind. Additionally, for new features, for example, with time series and with AutoML for NLP, we use the sort of canonical data sets for those. So for example, I think there's the M4 and the Numenta that we're incorporating now. And for NLP, there's the Glue, there's the Stanford IMDb movie reviews, and there's Squad for question answering. I hope that answers that.
Okay, we have a couple more questions, and Patricio answered them in the chat. But can we do categorization or classification, and how about clustering? So, yes to categories and classification, but we don't currently do clustering. Oh, so there's another question. Anatoly missed something about Looker. MindsDB operated with data in local ClickHouse database. What was the role of Looker? So if anyone else wants to fill in the details, but Looker is the visualization layer on top. Also, the data is stored within Looker, so Looker has its own SQL data store, and we're directly querying that and then representing, as you could see, as Patricio was running some of the training and inference, then you could represent that in a graphical format within Looker. The other question from Joao is, in terms of the integration with Looker, is it expected to be just focused on the presentation layer, or will it be associated somehow with LookML? So currently it's the presentation layer. I think that's the main benefit there, is to use the Looker visualizations and also Looker strong SQL support to make that easier and to be able to represent those directly in the Looker UI.
Yeah, I can add to that a little bit, just that Looker is basically going to operate in this case as a real-time SQL compiler. So you'll be able to take your data and consume the predictions in line, and then your end user will be able to put those together ad hoc, so they can really ask as many questions as they want to visualize them the way that they might want to, and even schedule that out so that, say, there's a prediction value that falls outside of a specific range. We could use the Looker engine in that case to alert us via email that something might be going to happen, so we can proactively take action on that.
It is actually very related to the last question that Natasha answered. So basically, anomaly detection is a feature we have for time series. And yeah, the idea there is, as soon as a prediction falls outside of, or rather, as soon as the true value of whatever you're measuring falls outside of what the predictor thinks, you will get an alert. There's a channel of communication that the predictor emits, and you can listen to this in a stream, for example, or in Looker. So yes, that is a feature we have.
I've got a few more questions coming in on the questions tab. So Konstantin asked if they already have pre-built models of their own, so TensorFlow or PyTorch or Scikit, can they use them within Looker? And the simple answer is yes. You can bring your own models to Looker, and there are a few other benefits. So there's some operational things that you can use, like model versioning and maintenance that Looker will support. Currently, we support models built in PyTorch and TensorFlow and other frameworks, TBD. A few more questions. So Konstantin again, what ML libraries are inside MindsDB? Is it open source? Yes, it is open source. For heavyweight modeling, PyTorch; for lightweight, scikit-learn; and for the language transformers. Oh, sorry, I forgot scikit-learn for the previous question. Another one from Konstantin. What is the performance of forecasting in Looker with large data sets? And I think, Natasha, maybe you can just jump in here.
Actually, I think Patricio has a little bit more experience with that.
Sure.
Yeah, let me see the performance of forecasting Looker. Yeah, so Looker really is, as it was previously mentioned, that it has like a presentation layer of sorts. So it interacts directly with MindsDB through SQL protocol, and then MindsDB internally uses the model to predict in batches, basically. So the bigger your batch, the more you can leverage, say, for instance, GPUs or a CPU if you have lots of threads, to make a faster prediction. So in general, once a model is trained, depending, of course, on the data types, but in this case, for time series, you can predict for hundreds of time steps a second. So it is pretty scalable.
Thanks. In the chat from Jason Kung, what could I do if my predicted output class and my anomaly detection system are weird? So I think maybe you define weird here, but I don't know if we could elaborate a little bit.
Well, I can comment on, the system we have for anomaly detection is unsupervised, and this means that you don't really need labels in your data to flag anything as anomalous, and then the predictor will do its best to figure out what looks anomalous in the context of the rest of the process. Now, this is convenient on the perspective of not having to compile data, but on the other hand, it might be that having a supervised approach can yield better results. So if your predictions are weird, it's possible that an unsupervised approach is not the best way to go. I'm assuming that's what you mean by weird, but there is that that caveat there.
Yeah, and feel free to type follow on in the chat for Jason. Anatoly is asking, are there any UI tools in MindsDB to explore data anomalies and model performance without Looker? So, I mean, obviously Looker has a full suite of BI visualizations and tools that we don't have, but MindsDB Scout does have some visualization features. Maybe Patricio, if you want to dive in here a little bit.
Sure. Scout gives you a general sanity check on what's important for each model, the amount of data that it used to train, to test. And then we have some tools that are in other repositories, not Scout itself, but you can clone them, and they're sort of internal for internal usage, but we're trying to expose them to Scout in the near future. And those are basically to get some of the visualizations that Natasha showed, which are, the true series that happened in the context of a time series task, right? And then the predictions and the anomalies. So that's a tool that I'll actually post the link if you want to try it out. But again, Looker does have very sophisticated visualizations. We do not at the moment.
Are there any further questions? And you can always reach out to us at mindsdb.com or over social media. The presentation will be available as well. And thanks to you, Anatoly, as well. Any further questions from anybody? I think if that's about it, I mean, please, the presentation will be available. We'll have the video on demand available as well, and please reach out to us. You can find us on GitHub at MindsDB with a full set of documentation. And MindsDB is open source. You can try it out yourself. And I'd like to thank everyone for attending.